Hey y'all, it's me, Miss B. Today we're talking about the cosine of the difference of two angles. We'll also be talking about the sine of the difference, and we'll also do the sum. So it's going to end up being 4 formulas. But at first, we're only going to focus on the cosine of the difference of two angles, just to get us adjusted. Okay, for the most part, it's just a plug and chug formula where alpha is an angle and b is a different angle. And then, so we have cosine of alpha minus beta is equal to cosine of alpha, cosine of beta plus sine alpha, sine beta. Okay, and the reason this is useful to us is because we can use common angles like 30, 45, 60, and 90 that are on our unit circle to find other angles that are not on our unit circle. So jumping into our first example, it says find the exact value of cosine of 15. Now, 15 degrees is not on the unit circle. Okay, but 15 is equal to 60 minus 45, and both of those are on our unit circle. So we can write this out as cosine of 60 degrees minus 45 degrees. Using our formula, I'm going to call this alpha and this beta. So I have cosine of alpha, 60, cosine of beta, 45, minus sine of alpha, 60, times sine of beta, 45. All right. Now, to finish this out, we're going to have to do some multiplication and subtraction, but notice, there should be a plus in here. Notice that you need to know your unit circle in order to do these problems. Okay, so cosine of 60 degrees is 1/2. Cosine of 45 degrees, remember these are being multiplied together, is radical 2 over 2. Sine of 60 degrees is radical 3 over 2. And sine of 45 is radical 2 over 2. Then we want to simplify, so multiply straight across. We're not cross multiplying because there is no equal sign in there. So then we get radical 2 over 4 plus radical 6 over 4, because radical 3 times radical 2, you multiply the insides together and keep the radical. Those don't simplify, so we get radical 2 plus radical 6 all over 4. Okay, now sometimes we'll be given problems where we have to work the other direction. So remember, we can go from both sides of the equal sign. So here I have cosine of 80, cosine of 20, plus sine 80, sine 20. Now you'll have to add this in because it wasn't in your notes initially. That was a typo. Okay, so I have a plus sign here, which means I'm going to do cosine of alpha minus beta. Now, 80 is we can call our alpha. This we can call our beta. So we get cosine of 80 minus 20. And we get cosine of 60 degrees. Now, let's just take a second and say you mixed up and said, okay, well, I had this is beta and this is alpha. Okay? If you did that, you would get cosine of 20 minus 80, which is cosine of negative 60. But remember, using the even-odd identity, you get just cosine of 60 degrees. So with cosine, and I want to write with cosine and cosine only, order doesn't matter as much. And that is because of the even-odd identity. That is not true for sine or the others. Okay, this next one here, this is a verification. So let's start from the left. You'll notice I have cosine of alpha minus beta. So let's go ahead and write out our formula. That'll be cosine alpha, cosine beta, minus sine alpha, sine beta, all over sine alpha, cosine beta. Remember, we only write from one side of the equation. Trying to get to cotangent and tangent, so let's go ahead and split our fraction. So we get cosine alpha, cosine beta over our denominator, sine alpha, cosine beta, minus sine alpha, sine beta over sine alpha, cosine beta. Okay, now that we've split, we can cancel stuff out that's in common. And so we end up with cosine alpha over sine alpha minus sine beta over cosine beta, which is cosine over sine is cotangent of alpha. Sine over cosine is tangent of beta. And we are done. Okay, so here you have your sum and difference formulas for cosine and sine. I do need to make a few edits though. So cosine and the cosine ones are right. We've got plus, that becomes a minus. This minus becomes a plus. Cosine alpha, cosine beta, sine alpha, sine beta. There's no change. The sine ones are a little bit weirder. So we want to make sure our signs are the same, so change that to a plus sign. And then we need to make this a minus sign here. We want those two things to match up for sine. Okay, so our signs, that's a little weird, should match up for those. Okay, I always keep alpha, beta, alpha, beta. That way those stay in the same place. However, you'll notice that we have this one we have cosine, and this is cosine, cosine, and cosine, and then we have our signs on the other one. So just make sure you're being super careful about what you are writing where. Okay, and pick up on those patterns as you're writing down the formulas. All right. So it says find the exact value of sine of 7 pi over 12 using the fact that 7 pi over 12 equals pi over 4 plus pi over 3. So sine of 7 pi over 12 is equal to sine of pi over 4 plus pi over 3. And then we want to use that sum formula. So I'm going to call this my alpha and this my beta. Okay, so I'm going to have sine, or we always put sine first. Alpha first. So I always start with sine of blank, cosine of blank. And then it's same sign for sine. And then we switch, so cosine and sine. Then alpha and beta go in accordingly. So it goes alpha, alpha, beta, beta. Take a second and get that written down. Okay, then we want to evaluate. So sine of pi over 4 is radical 2 over 2. Cosine of pi over 3 is 1/2. cosine of pi over 4 is radical 2 over 2, and sine of pi over 3 is radical 3 over 2. We'll simplify, we get radical 2 over 4 plus radical 6 over 4, which is radical 2 plus radical 6 over 4. Okay. This last one here, this is more of a help on setting up for future problems. Okay, so it says, suppose that sine of alpha is 12 over 13. And for a quadrant 2 angle, and sine of beta is 3 over 5 for a quadrant 1 angle. Find the exact value of cosine alpha and cosine beta. Okay, so sine alpha is alpha is in the second quadrant. Sine is opposite over hypotenuse. So the opposite side over here is 12, hypotenuse is 13, making this final side 5. Then sine of beta is in the first quadrant. Let's make it slightly different. Here's beta, and it's a 3 over 5, so opposite over hypotenuse. And we know that this final side is 4. And for both of these, we used special right triangles. That's how I got those so quickly. You can use Pythagorean identity if you want to. Okay, so then cosine of alpha is the the adjacent over hypotenuse. And cosine of beta is adjacent over hypotenuse. And so there are both of those. Now, like I said, that's just going to be helpful for setting up future problems. So there's an example of how to draw those pictures so that if it asks for how to solve those later, you could do that.